In this problem, we have three unknown forces, but we do know all of our angles. Let's go ahead and start writing these out. We're going to have a force normal based on this pylon. We basically have a big slab of something resting on one side on some kind of weight, and then let's imagine that these have tethers. And so we've got force 1, we've got force 2, force 3, force normal, and below that, we do have one more force that isn't listed yet. It's force of gravity. And so our force 1 is known. It's 120 degrees, or 120 newtons at 40 degrees. Now, we know the angles for these other ones. This F2, that's going to be at 20 degrees. F3 is going to be at 30 degrees. And Fn is going to be at 90 degrees. Force of gravity is also going to be at 90 degrees. So our key here is going to be setting up our equilibriums. First, we're going to have an equilibrium in f of x. So the forces in x are all going to equal 0. What are the forces I'm going to have in x? Well, first off, I'm going to have F1. F1 is going to have an x component. Then F2 and F3 will also have x components. So then I'm going to go ahead and simplify that right away. It's all going to be equal to 0. And then F1x, that should be equal to F1 times the cosine of theta. Then F2 cosine theta. Now if I apply numbers to this, F1 cosine theta, I have all those numbers. F1 is 120, its theta is 40 degrees. Let's calculate that. All right, when I simplify these expressions, I get 0 equals 91.9 plus 0.94 F2 plus 0.866 F3. Now, these points are going to be my cosine values because I already have those angles. I can simplify that and just get a number out of it. Then I don't have to worry about this cosine function anymore. So what I want to do here is I'm going to subtract 91.9 from both sides. So I get negative 91.9. Now what I want to do here is I want to solve this equation for one of my variables so that I can plug it into something else later, or plug something else into it later. So I'm going to solve for F3. So I'm going to subtract F3 from both sides, 0.866 F3. And I'm going to divide both sides by negative 0.866 so that I can get just a clean value. And when I do that, I get F3 being equal to negative 106.12 plus negative 1.09 F2. Now, that should help me nicely later on. I've got one of my equations set up, and this is going to be my x. This is going to be for my x. Now let's set up the y. So I've got my F1, 2, and 3, they're y components, but what else do I have in y? In y, I also have the force of gravity. That's going to be pulling this down. And I also have the force normal from this pylon pushing up. So I'm going to have to add those in as well. Now let's break all of these variables out. I've got F1, and this will be times the sine of theta, F2, sine theta, and F3, sine theta, plus force of gravity, plus force normal. So this is what I've got when I break all of those variables out. What I want to do next is I want to put some numbers here. But before I can really do that, I need to consider something. Which direction are my values going to be in? I need to pick a positive and a negative. Now, generally speaking in forces in y, up is going to be positive, down is going to be negative. Okay? We didn't have to do that for the x's yet because we only had one of our numbers for x. So we basically just said, hey, this f1, we'll call that positive. But when we did that, we defined to the right as positive and to the left as negative, which means F2 and F3, their x components are going to have to be negative. But with the y's, well, I've got F1, that's going to be a known value, and my force of gravity, that's going to be a known value. So we're going to be able to use those actual numbers, but they're going to be negative because they're going down. F3 and Fn, those will be positive, they'll be going up. But F2, that'll be negative, that'll be going down. So let's throw those negatives in here, and let's actually get the numbers for F1 sine theta, for Fg, and for the sine thetas of my F2 and F3. So when we do all of that, we're going to actually get some numbers. So once again, I've got negative 77.1, I've got a negative 196, those are both pointing down, and my F3, that F3 should be, oh no, that should be F2. F2 should be negative. Next, I'm going to rearrange this equation so that my numbers are all on the left side. So now I've got my equation for my forces in y setup. This one I'm not solving for one variable because I have 3 different variables. So I'm going to end up using this one later on. I'm going to be able to substitute stuff into this to make other stuff make sense. So now we have one more equation we need to set up, and that is our equilibrium in torque. Now, the first thing I do with my torques is I always break them out into their individual forces, the actual equation that makes the torque. Because I have forces, but I'm going to have to solve for torques. So it's going to be F1 times R sine theta. And that's going to be the same for each of these. Now, before I can do anything else with this equation, I need to be able to figure out the values of all of these r's. And just like in the previous problem, I'm going to do that by picking a rotation point, picking a pivot point. It doesn't matter where that pivot point is because this is stationary. Remember, I could pick that pivot point somewhere out here, but putting it there wouldn't really help me. Wherever I put my pivot point, if I put it at the location of one of my forces, if I put it here or here, that r would become 0. And so I can do that strategically. Now, clearly, I'm going to want to do that. I'm going to want to pick a pivot point that's going to be at one of my unknown variables so that I can use this equation a little more easily. And so what I'm going to do is I'm going to look at my other 2 equations. I'm going to look at my fx and my fy. Now, fy has f2, f3, and fn all in it. So it's a horse apiece. But fx, that doesn't have my force normal in it. And so if I can make my torque equation to get rid of the force normal, I might be able to make that work in either of these equations and substitute it in to be able to solve something. So I don't know what I'm going to solve for yet. I'm not that far ahead, but I see that F3 and F2, I have those in both of these equations. So I want to try and have both of those in my torque equation too. I want to try and be consistent with that. Because the more equations I have those variables in, the more I can check and substitute in. So I'm going to pick this right here as my pivot point. And that's going to be 1/5 of the total length in. Well, my total length is 4. And so 1/5 of 4 is going to be 0.8 meters. So this pylon right here, this is at a location of 0.8 meters from the end. So when I figure out these numbers, I need to consider them from that point. So the R for F1, the R is going to be 0.8. And that's going to be because I'm using this spot as my pivot point. If I used the end, well, then for F1, the R would be 0. If I used the other end, if I said pivot point right there, then this would be 4 meters away from that pivot point, and I would say this would be 4. But I'm not. So I'm using this pivot point that's giving me 0.8. Now I want to figure out what are my pivot points going to be for my other forces. For Fg, well, that's going to be halfway. So that's going to be at a point that is at 2 meters. Well, what's 2 meters away from 0.8 meters? It's going to be 1.2. So my R value is going to be 1.2. F3 is 3/4 out. Well, 3/4 of 4 is going to be 3. So that's 3 meters in. And then what's 3 meters further from 0.8? Well, that's going to be 2.2. I'm going to use 2.2 meters for my R value for F3. And then F2, that's at the far end. So that would be at a distance of L, which would be 4. And what is 4 minus 0.8? That's going to be 3.2. And so those are all of my R values. So I'm going to bring those back over to my torque equation, and I'm going to plug them in. So I'm going to actually break this out into as many numbers as I can so that I have just a few variables. Now, with all of these numbers plugged in, I'm going to make all of these as simple as I can. The first thing, 0, cancels out. Next, 120 times 0.8 times the sine of 40, followed by 3.2 times the sine of 20, 2.2 times the sine of 30, and then 196 times 1.2 times the sine of 90. I'm going to get all of those numbers, and then I need to go back, and I need to figure out which ones are going to be negative and which ones are going to be positive. All right, I've gotten this as broken down as I can. I need to figure out which direction these are going now. If we remember, our torques are always going to be clockwise being negative, counterclockwise being positive. So anything that is going around this way from my pivot point, or this way from my pivot point, that'll be clockwise, and that'll be negative. Anything going that way will be positive, going that way will be positive. So F3 is on this side of my pivot point. It's on the right side of my pivot point going up. That would be positive. So F3 is positive. F2, that'll be going down on the right side of my pivot point. So that'll be negative. F1, that'll be going down on the left side of my pivot point. That'll be positive. And the force of gravity, that'll be going down on the right side. That'll be negative. So force of gravity and F2 will be negative. F1 and F3 will be positive. So now I've got my negatives in place. I've got all of my numbers actually out there. This is all going to be equal to 0. So I'm going to simplify this as best as I can. And then I'm going to solve for one variable. Which variables should I solve for? Well, I'm going to look back at my forces in X. I solved for F3 over here, so we can keep that pattern. So I want to solve for F2 in my torques, so that then I can substitute this in and then solve for F3. And then I'll get one of my variables. And then it'll just be knocking them down one right after the other after that. So here, 61.7 plus negative 235.2. So now I'm going to divide both sides by 1.1, and I'll have an equation that I can substitute. And now I'm going to plug this equation in for my F2 and my X. So let's take this guy. And we'll plug that in. So when I merge these together, let's use yellow for this. I'm going to have F3 equals negative 106.12 plus negative 1.09 times, and then I'm going to plug all of this in for F2. Negative 157.7 plus F3. Then distribute those numbers. And then I'm going to put these two together, negative 106.12 plus 171.89. And I'm going to add a 1.09 F3 to both sides. And then I divide both sides by 2.09. And I've got my first force. F3 is going to be 31.5 newtons. Now I can plug that in back right here, And I'm going to be able to solve for F2 right away. So then I've got the value of F2. I've got the value of F3. And so I can plug those in to my y equation, solve for the force normal. All right, before we put any of this together, let's look at this one important note. This 126.2, we have this being negative right here. However, in this problem, we already accounted for that right here. So we don't need to put another negative there. So when we solve this, our negative for this problem is already right here. Our F2 in y should be negative. When all of this gets multiplied together, that's our F2 in y, which we can see over here would be a downward vector. So that should be a negative in that equation. If we have a negative times a negative, that'd be a positive. So that is going to be one part of this that can be really obnoxious, is just keeping our negatives and positives straight. But if we refer back to our drawings, we should be able to see which terms should be overall negative, which ones should be positive. So now I've simplified this back down, and I've got negative 274.41 plus Fn. So I'm going to add 227.41 to both sides. That gets me 300.51 equals Fn. So after a lengthy process of creating three separate equilibriums, we are able to solve for all three of our missing variables. And if we wanted to check this work, we could take any of these numbers, being cognizant of which direction they're pointing, plug them into any of our equilibriums, and verify that we are getting close. If I take these numbers, considering in my x that my F2 and F3 will be negative, and my F1 will be positive, then I come out to about 0.6 with those numbers, which is very close to 0. If I do the same thing with my y values, considering that the y of F1 will be negative, the y of F2 will be negative, and the y of force of gravity will be negative, I get 0.03. And so by checking these numbers, I can verify that my values are correct.